What's going on, you guys? Mr. Allen here. We're about to solve for x and check for any extraneous solutions in these radical equations that we got going on right here. And yes, we can have extraneous solutions in radical equations just like we had them in rational equations, but it's a little different. In rationals, we can't divide by 0, right? That's the no-no. What are we not allowed to do with radicals? I can't square root, say, negative numbers, right? Or any kind of even root like a fourth root or whatever. All right, so we're dealing with square roots here in this one. How are we going to go about solving this? Well, I got to isolate my radical. This guy already is. So I'm going to have to raise both sides to a power of 2 to cancel out that radical. So I'm raising this side to a power of 2 as well as this side to a power of 2. You got to raise the whole side to that power of 2. This is going to cancel my radical, and I'm left with here 2x plus 30 equals. What happens with that x plus 3? And if you say, I'm going to distribute that exponent into this binomial where there's addition or subtraction, I am going to scream, okay? I don't want, no, you can't do that. You can't distribute that exponent when we have addition or subtraction happening. You have to think about this one as x plus 3 times x plus 3 and distribute, FOIL, whatever you want to call it, right? We got to go through that process there, okay? So do not write down x squared plus 9. I will scream, not okay. All right, got a little worked up. Let's calm down. Let's calm down. Let's go back to the math. The math calms you, you know? I don't think that's the case for everybody. Okay, 2x plus 30 equals, I'm going to have x times x is x squared. X times 3 is 3x. Then I got 3x again. And then I've got positive 9. All right. Let's combine some like terms, shall we? We shall combine some like terms. I can't on this side, but I can on my right-hand side. We got plus 6x, bro. And I got plus 9. All right, I'm dealing with a quadratic. And usually our minds go to mush when we see a quadratic outside of our quadratics unit. We don't remember how to solve it. We start doing illegal math all over the place. Panic mode sets in. We're not. We're focused. I'm going to set this thing equal to 0. Okay? When I solve a quadratic, I got to set it equal to 0 for pretty much every way we want to solve them, except for completing the square, which who would do that on their own? All right, so we are going to subtract 2x on both sides, and I'm going to subtract 30 in this same step, right? If we're solving a quadratic, I want to set it equal to 0, and I want to get everything on the side where my x squared, my quadratic term, is positive. And since this one's already positive, I'm leaving it as x squared on the right-hand side, right? I don't want negative x squared. Don't try and factor with a negative leading coefficient. It never goes well. I don't think anyone's ever done it successfully, okay? So I wouldn't suggest it. There we go. All right. Now, what multiplies to negative 21 and adds to positive 4? Well, that'd be x plus 7. 7 and negative 3 will multiply to negative 21 and add to 4. So this means I'm going to have x plus 7 equals 0 and x minus 3 equals 0, thanks to my wonderful zero product property, right? If I get this equal to 0, anything multiplied to 0 equals 0. If I get this bad boy equal to 0, we Gucci there too. All right, so I got x equals negative 7 and x equals positive 3. Now, before I go ahead and circle these bad boys, put a little smile on my face, right? I got to check for extraneous solutions, okay? Now, how the heck do we do that? There's a couple ways. If I plug something in and it causes a negative inside of my square root, it's no bueno. But I also have to see, what if my square root were going to be equaling a negative number? That can't happen either, right? If I plug negative 7 in here, I get negative 14 plus 30 is 16, okay? And then square root of 16 is 4. Cool, that's no big deal. But when I plug it in over here, I get negative 7 plus 3 is negative 4. Does 4 equal negative 4? No, it is an extraneous solution. All right, so it does not work in the original context of the problem. So it's not as easy to spot these as it was in the rationals unit, where you'd be like, well, I just listed my domain restrictions, we're good to go. Here it can happen kind of in a weird way, right? But if I plug 3 in, I get 6 plus 30 is 36. Square root of that is 6. If I plug the 3 in over here, I get 6. 6 equals 6. This bad boy is good to go. All right, our first extraneous solution. That was really exciting. A big moment for all of us, you know, right? Okay, cool. Let's do another one, shall we? We shall. Okay, so right now I don't have my square root isolated, right? I don't have my radical isolated, and that's not radical. So I'm going to add 4 to the other side. I'm going to have 3, and then I'm going to the square root of 2x equals, and I'm going to write it as x plus 4. Now, normally we would like maybe divide by 3 on the other side, and then square both sides. But because of how I'm seeing this problem coming together, this is going to end up in a similar situation to this right here, a quadratic. I really don't want to deal with any kind of fractions, right? So I'm just going to square both sides right now. That's what I want to do. I'm going to square both sides. 2, I got to distribute my 2. My 3 squared, 3 raised to the second power, that's 9. And so this guy hits that, and then also hits my radical, that's canceled, and I got 2x here. So that's going to give me 18x. I'll write that in a sec. For this next one here, I have x plus 4 quantity squared, so that's x plus 4 times x plus 4. I don't have the luxury of distributing my exponent like I did here because it's multiplication between those two. I can freely distribute my exponent into that. It's not a binomial. Here it's a binomial. I cannot do that, okay? That's a no-no. Okay, 9 times 2, that's 18x equals, and then here I'm going to have x squared, and then it's plus 4x, that's going to be 8x plus 16. Multiplying those two same binomials together, you should probably get used to seeing, okay, it's going to be 4x for the outside, 4x for the inside, add them together is 8x. That'll save you a little bit of time, right? That's dope. I love saving time. All righty. Now, quadratic, once again, set it equal to 0 so we can factor, hopefully factor, and solve. I don't want to mess with the quadratic formula, bro. So minus 18x, minus 18x. I like to pop them underneath the like terms, right? So I'm just nice and organized. Boom, those are gone. I'm left with 0 equals x squared, and then we got minus 10x plus 16. All right, now it's time for a little factor land, right? What multiplies to 16 adds to negative 10? Well, that would be, let's see here, negative 8 and negative 2. Two negatives multiply to a positive, 16. Negative 8, negative 2 adds to that negative 10. So I get x minus 8 and x minus 2. All right, so now I'm going to have x minus 8 equals 0, x minus 2 equals 0, and I get x equals positive 8 and x equals positive 2. Now, you might be thinking like, hey, bro, we got two positive numbers. No big deal. I don't need to check for extraneous solutions at all. We still do want to check to make sure things work out. If I plug in 8, 2 times 8 is 16. Square root of 16 is 4. 4 times 3 is 12. 12 minus 8 is 4. So this one checks out. We're good there. How about the 2? Does it do the same? 2 times 2 is 4. Square root of 4 is 2. Times 3 is 6. 6 minus 2 is 4. All right. They do both work. Now, it's a little tricky to do that in your head. I know, I'm making it look easy, right? So it might be helpful to throw that into your calculator. You can always do that. You know, type it all in, see if it equals 4. Double check those things as long as your calculator is allowed on that portion of the test. But double check yourself before you wreck yourself. You don't want to have any extraneous solutions in the final answer. You go and lose some points. We don't want to lose no points, all right? The goal is to get all the points. Whew, that'd be dope. All right, you guys have a fantastic, radical day, and keep watching some dope math bits, right? Keep watching, like, subscribe, YouTube things. All right, deuces.